Hi class. In this lecture here, we want to continue talking about integration with substitution, but now moving towards working with definite integrals. And I'm going to show you two ways to do this. One way is when you change the bounds of integration and leave it as the variable u, and then another way is when you don't change the bounds of integration and you just have to substitute back in. And the first integral I'm going to show you both ways, and then the second one I'm just going to do using this theorem here where you do change the bounds of integration. Okay, so here's the theorem. This is the change of variables for definite integrals. If you have a function u is equal to g of x, okay, remember this is the inside when we're doing that integration by substitution, has a continuous derivative on the closed interval a to b, and f is continuous on the range of g, then you have the following. If you're going to do a definite integral from a to b of f of g of x times g prime of x dx, this is equal to g of b and g of a. So you're going the definite integral from g of a to g of b. So here you're changing the bounds of integration. And then you're just integrating f of u du here. And what you're going to do here is when you figure this out, okay, when this becomes f of u, capital F of u, when you integrate it using the fundamental theorem of calculus, you do not have to substitute back if you change the bounds of integration. In this, if you do not change the bounds of integration, you do have to substitute back. And this is a real simple concept. So I've got two examples picked out for you here. All right, so here will be the first one, and I'll illustrate all of this for you. So let's integrate, all right, from 0 to 4. 0 to 4, 1 over the square root of 2x plus 1 dx. All right. So again here, what you're going to have to do is you're going to have to let u be the inside of this square root, okay? So let's let u equal 2x plus 1. That means du is equal to 2 dx. All right, so I can substitute in for the dx. I just have to move this 2 over. So this is 1/2 du is equal to dx. All right. So I'm not going to change the bounds of integration just yet. Okay, so watch. This becomes 1 over the square root of u. And then dx gets replaced by 1/2 du. All right, now the bounds of integration, look what's going on here. Our theorem here says u is equal to g of x. So I'm going to evaluate u by plugging in a for x and then b for x. Okay, so watch. So we're going to change the bounds. So if you plug in 0 for u, okay, so u of 0 is equal to 2 times 0 plus 1, which is 1. So this bound of integration becomes a 1. And then now I'm going to figure out what 4 is when I plug in for u. So u evaluated for 4 is 2 times 4 plus 1. That gets me 9. So now I'm going to integrate from 1 to 9 for this function here, or for this expression here. So this is the integral from 1 to 9, definite integral. 1/2 u to the minus 1, minus 1/2 du. So watch what happens here. So this right here, this is going to integrate as 1/2, and then this is u, minus 1/2 plus 1. It's 1/2 over 1/2. And then I'm evaluating from 1 to 9. Look, the 1/2's cancel here. Okay, so you're actually just left with the u to the 1/2, which is the square root of u from 1 to 9. Now, since you did not change your bounds of integration, okay, or excuse me, I misspoke there. Because you did change your bounds of integration, you do not have to substitute back in. So this is just the square root of 9 minus the square root of 1, which is 3 minus 1, which is 2. So, you know, usually what we were doing when we were doing these integrals is you'd substitute back in. Now, suppose you wanted to do that, right? Okay, so imagine, so now I'm going to show you you're going to get the same answer. So what if you didn't change the bounds of integration? So you would still get this, right? So our original bounds of integration were 0 to 4. And then you still had this. You had 1/2 u to the minus 1/2 du. You're still going to do your u substitutions, right? So we see that this ended up being the square root of u, right? So this is the square root of u. If you did not change the bounds of integration, then all you need to do is sub back in for u. So this u was 2x plus 1. So this is the square root of 2x plus 1. Go from 0 to 4. And check this out. You get the same thing. Okay? When you plug in 4, you get 2 times 4 plus 1. You get the square root of 9. When you plug in 0, 2 times 0, 0 plus 1. So you get the same thing. So it's really up to you what you want to do. You know, do you want to change the bounds of integration? Or do you want to substitute back in at the end? Like, it doesn't matter. You'll get the same answer, okay? Sometimes, you know, just quickly changing the bounds of integration here is the easiest way to do it. All right, let's do one more here. And I'm going to do it by, you know, changing the bounds of integration. Okay, so let's integrate from 1 to 2. X, and then I'm going to have x squared plus 1 cubed dx. Okay. So again here, all you're going to do, I have the cubed on the outside, so I'm going to let u be equal to x squared plus 1. That means du is equal to 2x dx. Well, look, I have a dx and an x. So I'm going to move this 2 over. So this is 1/2 du is equal to x dx. So I'm going to change the bounds of integration in a second. So I'm going to replace x dx with 1/2 du. And then this x squared plus 1 cubed, well, that's just u cubed. And then look, let's change our bounds of integration. So u of 1, well, that's 1 squared plus 1 because I'm plugging in 1 for x. That's 2. And then u of 2, well, that's 2 squared plus 1, which is 5. So I'm now integrating, instead of from 1 to 2 dx, here I'm integrating 2 to 5 with a du. Well, u cubed integrates as u to the 4th over 4. And the 4 in the denominator times 1/2. This integrates as 1/8 u to the 4th power. So look, this once you get it here, this is just u to the 4th power. So this is 5 to the 4th power over 8 minus, and then 2 to the 4th power over 8. Well, 5 to the 4th power is 625 over 8. 2 to the 4th power, right? 2, 4, 8 is 16 over 8. And then 625 minus 16, that just gets you 609 over 8. So again, you know, the big thing here is you know, remembering how to you know, just do your u substitutions, and then just, if you change the bounds of integration like I did here, it's great. You do not have to substitute back in. And again, if you do substitute back in, okay, for you, just make sure you did not change your bounds of integration.